So it's 3 o'clock. Good afternoon and good morning and good evening in case to everybody joining today's webinar. My name is Giorgio Ceriani from Ejlskov, and today we are here to start a series of what we call coffee break webinars, covering a series of topics that we would like to address during this series. The agenda that we set up for today is to show the webinar series and give a little sneak peek of what we will cover during the sessions, go through the structure that Ejlskov and the RPI group has created over the years and how we normally address our projects, cover the main topic of today, which is the high resolution site characterization and remediation design, and how we support our data collection through the use of our ESM software, and then try to leave as much time as possible for a question and answer session. For submitting questions, you are more than welcome to use the lower bar on your screen to write down your questions, else you will be unmuted and you can also ask questions live. Mike Mazariz from AST is joining me today to support me with the Q&A session. Same thing for Palle Ejlskov, which is our CEO. So the sneak peek of the upcoming sessions in a few days, on June 20th, we will cover during our second session the installation part of slurries. As RPI group, we have spent a lot of years in developing custom-built equipment specific tools to be able to install properly suspended amendments when it comes to in situ remediation. We will then follow up after the summer holidays with two sessions focused on our main products, which are the trap and treat technologies, which have been on the market since 2002. Three different types of products which are used for both biotic and abiotic treatment of chlorinated solvents through use of BOSS 100, CAT 100, but also other compounds, as we will show when it comes to BOSS 100, with PCBs, linden, pesticides, and dioxane as some of those that can be treated by BOSS 100. And also we will cover with one session the BOSS 200 product, which is mostly focused on the treatment of hydrocarbons. We will then finish with a fifth session where we will cover one of our latest introduction in terms of tools available for in situ treatment remediation. In this case, we will talk about Fluorosorb, which is a product that we started to use for remediation of PFAS. So let's dive into today's session with the high resolution remedial design, and we will cover then, as we move through the presentation, the main feature of Ejlskov ESM modeling software. So when we start looking at where we come from, so Ejlskov was founded in 1999. Given our geographical position, we have been mostly active across the Nordics. We are based in Aarhus, Denmark, so we cover normally the Denmark, Sweden, Finland as the main markets, but we have done projects almost across all of Europe. And since 2015, we have also been active in China, both with high resolution site characterization, but also with in situ remediation. We have become a licensed installer within the RPI group since 2010, and since last year, we also become part of the SETCO licensed installer group for their technologies. As a remediation contractor, we work under total solution contracts if the clients allows us to do so, given the wide variety of tools that we have available in-house. And I would like to let Mike Mazariz give a sort of introduction to how we collaborate within the RPI group so that we can get a better understanding of how we collaborate internationally with our group of partners.
Yeah, thanks, Giorgio. as he mentioned, my name is Mike Mazzarese. I work out of Denver, Colorado, which is actually where RPI is based. I work out of their office. And AST's role in the RPI group is really to act as liaison between RPI and our installation partners, which are based in Europe, Australia, Africa, Canada, and here in the US, to provide technical support with respect to design for projects whenever it's needed, as well as the installation support as well. And that's for the RPI products, as well as for the recent addition of the Setco Fluorosorb technology as well. So thanks for having me, Giorgio.
Thank you, Mike. So moving on with our presentation, we can see within this slide how we tend to cover our total solutions, which start from doing the remedial design, high resolution site characterization on site, collecting both qualitative data, then moving into a collection of quantitative data, and then performing normally in-situ remediation by means of injections through our custom-built equipment. We have a wide variety of drilling machines, including a very small electric machine that has helped us in many occasions to perform injections in low accessibility areas. In this case, it was a very narrow basement. Within, let's say, the reach of normally Denmark, we are able to provide also our clients with vacuum excavation services, especially on active sites where you need to be extremely careful before drilling or performing any activities that may disrupt any of the site utilities. And the regular approach that we follow throughout our projects with our clients, normally consultants, is that we try to bring the project from a start to an end following very simple steps. So the general first step that we try to cover with clients and consultants is that we take all the available data that have been collected at the site historically. And what we try to do is to identify where possible data gaps are present when it comes to designing the final remediation effort. So one thing is having compliance data, one thing is having the right data to be able to design the remediation. So we like to introduce this second step, which we call remedial design characterization. And what truly is not a characterization per se, but it's an effort where we try to collect the residual data that are needed for us to be able to design a remediation that wants to take the site to a closure and not just to patch the problem. With all that data, we are then able to refine the final remediation plan and possibly also improve the risk assessment that the consultant has already prepared and discussed with the authorities, since we have a lot more data. And then go into the active remediation phase with a lot more confidence, again, due to the fact that we have better data available and we can use now the budget that is available for the remediation a lot more efficiently. Following the remediation, thanks to the support we have within the RPI group, we can provide the client with access to performance data, both on soil and groundwater, where we can get access to free analysis through our partners at RPI. Why do we consider the RDC so important? So the reality is that we try to identify those areas where, let's say, most of the contamination may be present, but within high density data, you may just not find it through, let's say, regular compliance site investigation. So by using qualitative and quantitative data, we try to establish exactly where the contaminant mass has been distributing over the years. So finding transition zones that could be sands to clay, or thin layers where a lot of contamination may have been accumulating over the years, and so forth and so on. One important thing that we have seen over the years that it's more linked to how maybe the local legislations have been built over the years is that in a lot of countries, it has been, let's say, general practice for clients to be allowed to collect soil samples, mostly in the unsaturated soil, because the legislation just required that. But when it comes to the, let's say, real field conditions, then we have seen that most of the remediations were failing because the soil mass estimation was not done properly. So we like to go into saturated soil and try to collect as much soil data as possible, because we can see that you can easily underestimate by 80 to 90% your mass estimation just by looking at groundwater data instead of soil data in the saturated layers. We then also try to understand the links that are present between the soil contaminant mass, so how the volume and the distribution are connected, and which are the migration pathways present in our CSM, and how we can be more efficient in addressing those migration pathways in order to achieve the final objectives and criteria for the remediation. The other benefit of doing an RDC is that before going and do an in-situ remediation, normally as we do by injections, we can understand the drilling conditions at the site. Sometimes it's not straightforward to be able to drill by direct push into a specific type of geology. So by being there ahead of time and starting to do some drilling, we can figure out if we need something different to be able to then complete the remediation down the road. When it comes to budgeting of a proper RDC, our rule of thumb is that if we have a preliminary remediation budget that we can estimate based on the available data, we would normally look into a 5 to 15% of that budget to be allocated for the RDC in order to finalize a solid design. So starting going into the visual part of what we try to do with the remediation design, this is a slide that wants to show how we shift the focus from the compliance data to the remedial design data. This is an example from a site that had been treated with regular, let's say, traditional remediation methods for more than 15 years. The client had the understanding that the contamination was centered around one single well, and then 15 years down the road, nothing was truly happening. Once we came in and designed better the remediation, we were able to find out that the reason why the previous attempts didn't work was simply because most of the contaminant mass was not even found. By doing this qualitative assessment, what we try to do is to generate the data. So we use the bridge as a sort of metaphor, because when you're going from compliance to end of the remediation, you can just try to go from A to B without any data, or you can try to collect all the necessary data and parameters that are needed to build your bridge in a solid way so that you can actually get to the other end in a safe way. How do we generate the data? So as discussed, we try to use qualitative data. Most of you following this webinar are probably familiar with the MIP, with the Membrane Interface Probe tool. And what it is, it's just an heated probe that is hammered into the ground. And at each interval, the user decides if you want to advance it 30 centimeters at the time, 40 centimeters at the time, 50 centimeters at the time. But most importantly, what you do is that you collect high resolution qualitative data as you go through your subsurface by heating up the soil, desorbing the contamination that may or may not be present in the formation around your probe. That contamination will enter a semi-permeable membrane placed on the heated probe, and then a carrier gas will carry that gas stream over to the mass detector and the instrument that we have in the field, so that you can get a signal of how much contamination you may have at different depths. This is an example profile of what you can obtain by using MIP. The first graph is the EC, so you get a feeling of the soil type that you may be drilling through. This is, for example, a site where we had an overburdened clay above a fairly, let's say, permeable aquifer. Here you can see definitely, based on the historical information, we know that the aquifer was approximately 8 meters below ground level. Here we could identify definitely the presence of a source, in this case a chlorinated type of source. And then as soon as you enter the water table, you could definitely see a large amount of contamination being present. All this, though, has to be quantified. How do we do that? Is that we collect, based on the MIP data, a large amount of both soil and groundwater samples. Through the support that we have from RPI, we are able to send hundreds of samples to the US, get them analyzed for free. RPI follows very strict protocols when it comes to performing analysis, because it goes of our quality at the end of the day. So we want to make sure that the design is done in the best way possible. All VOCs analyses are done under EPA guidance on GCMS 8260, but we can also analyze other type of contaminants under EPA GCMS 8270. Throughout the whole lifespan of a project, this support is granted for free again, also for all the groundwater samples that can be generated post-injection. And we have a series of compounds that we like to follow in order to ensure that then the remediation has been designed, implemented, and it's working as it should. This is also a visual output of what we can generate with all the data. This is a site where we did a very large remedial design for a client that is in need of redeveloping these former industrial properties. We collected we performed roughly 125 MIP points to an average depth of 20 meters. In total, we drilled roughly 2.5 kilometers when it comes to MIP. We collected then roughly 30 to 35 soil core location, and that was thanks to the MIP telling us exactly where to perform the sampling. We had 700 soil samples analyzed for free, which roughly leads you to a saving of 50,000 euros on the whole project. And with that data, we were also able then to generate a cluster of monitoring wells for design purposes, which were screened at specific depth. And as you can see as an output, the design of the injection was done following all that high resolution data generated throughout the RDC phase. Sometimes the MIP is not available, or the geological conditions can be a little bit tricky for the MIP. So this is a site, for example, where, again, the initial CSM was based on some soil data, but probably not enough. There was a constant issue with the groundwater at this site being contaminated, and the authorities wanting to have a protection from, let's say, a risk of that contamination constantly migrating off-site. In this case, by using dual tube sampling, we were able to actually find out that to do injections at this site, we would have needed to go through a phase of pre-drilling because of the presence of 11 meters of totally bone dry sands. But at the end of the day, during the RDC, we were also able to collect up to 425 soil samples, create a very detailed model of where the residual soil contaminant mass was present. As mentioned, the authorities were mostly concerned about groundwater quality at this site, and this allowed us to create an injection design which was focused on creating an horizontal barrier so that that overlaying contaminant mass would not threaten the groundwater aquifer anymore, and at the same time create a downstream barrier at the site to protect further migration of contaminants off-site. This site was completed between RDC and remediation between 2017 and 18, and we obtained a no further action in 2021. Similarly, again, for redevelopers, this is more of a typical case when it comes to Scandinavian conditions, where bedrock conditions can be very tricky to understand. We had a redeveloper who was very keen in mapping the whole property that they were about to demolish prior to continue with their construction project. And here, as you can see, the RDC was focused on truly following a specific grid with the MIP and make sure that we had covered as much as possible the property and ensure that the client was sure regarding the presence of contamination. In this case, we identified the source in an area where actually previously no data showed any sign of contamination. We were able to separate the soil contaminant mass from the groundwater plume. We were able to generate a very detailed profile of the bedrock, which made perfect sense with the groundwater flux. The light blue zones are where the bedrock is at the deepest. And in this case, we could see a plume migrating off-site, originating from the source. The client had already a plan for construction of underground parkings at this property. So the whole remediation and design and construction planning came together, because then we were able to target our remediation simply on where we had to protect groundwater and let the client take care of the excavation part and removal of some of the soil mass as part of the construction process. This is another possible output of a remedial design of an RDC when it comes to, for example, oil and gas clients. Here we have a gas station that had been undergoing in situ remediation for a number of years following a total rebuild of the site infrastructure. Despite the efforts of the previous remediation system, there were no clear improvements in the groundwater conditions. Recently, we have been asked to try to understand where the contamination may have been not truly scanned. We did an RDC, which led to a much better understanding for the client of where the contamination was present and why the remediation had not been 100% efficient till now. But most importantly, what we can provide to, for example, oil and gas clients is that by inputting in our software all the available information when it comes to site infrastructures, being USTs, oil water separators, and things like that, we can create a total mapping of the property that allows the client to get a proper value estimation of the site. And when it comes to having multiple properties and have to allocate budget based on possible, let's say, risks related to how much contamination is present on site, you can get a much better picture by using all the available data and storing them into a 3D software like we have available. Here we can see as a flyby how we can also help all the stakeholders to visualize better the site conditions. We can generate all these views with our software. We normally see during, let's say, authorities meeting, client meetings, that all this information visualized in 3D rather than sometimes in an Excel table helps a lot in getting everybody on the same page when it comes to understand the site conditions. And ultimately, one of the features that we also like to use with our high resolution data management software, ESM, is that if you're looking at other type of remediation solutions down the road, which could be, for example, excavation, we can still provide clients, for example, with a detailed overview of the mass estimation and the distribution by doing specific cutoffs, both in terms of concentration, lateral extent, so that you can estimate in a much better and accurate way how much soil you will dispose off-site and the level of contamination that you may expect, so that you can budget your, let's say, dig and dump project in more accurately. This was pretty much what we wanted to present today. We have, as we transition into the question and answer sessions, we have a couple of clips which we will play just to show you some of the features that we have available with our software. And Mike, if you have something listed out in the Q&A section, just let me know. Thank you.
Yeah, thanks, Giorgio. So if you do have any questions, as Giorgio mentioned down at the bottom there, we've got a chat box, but also a Q&A box. So go ahead and put those there, and we'll go ahead and get those addressed. I guess to get things started, Giorgio, if you could give just sort of a obviously it's going to be very site specific, but kind of just a range of costs for the modeling piece, maybe from like kind of maybe give a range of like a small to like a large site.
Correct. So when it comes to the use of the ESM, we normally provide a lump sum based, as you said, on the size of the site, the amount of data available. We could look into as little as maybe 3,000, 4,000, 5,000 euros as a lump sum, and we could have large size, like if we take the one where we did 125 MIP and 35 soil cores and 60 plus monitoring well. You could end up with maybe 20,000, 25,000 euros, or sometimes a little bit more. As Ejlskov, we are actually working now on trying to license out the use of the software, both in a viewer mode for those that would still like us to make sure that the data input is performed in the, let's say, most efficient way. And at the same time, we are looking maybe at partners who have sort of an in-house GIS group that could handle the whole, let's say, raw data inputting, but at the same time, the visualization part.
Excellent. Do you generally, how do you see, I guess this could kind of paraphrase the question, how do you see the scope of work change sort of pre-RDC to post-RDC?
The main advantage we see by using the RDC is that, as we said, we can estimate a remediation budget to start with. So let's take the number like 100 worth of budget that we could look into when we are given some data for the to design a preliminary remediation. If we use 10% of that budget to do an RDC, so we use 10, the remediation could still go into a total budget of 100, but definitely the key advantage is that we will be able to use that budget a lot more efficiently. So rather than having a remediation done, let's say, more homogeneously across the whole site, where you think like, oh, I have to assume that that area is as contaminated as another area. With the extra data available, I may find that there are 100 square meter worth of that property that really have a lot of contamination, where I need to use more budget, and then I may find that another 100 square meters are actually not impacted at all, so I can avoid do any remediation in that area.
Okay. I guess just another question: how do you can you use these same because a lot of what you showed are really source areas? How would you use these techniques for the RDC and I guess the ESM to a certain degree if you were looking to install a permeable reactive barrier?
Right. Data collection when it comes to source zones versus PRB, I guess it's a discussion that we have with consultants and clients. So if ultimately the remediation can be performed at the site, only at the site boundary, let's say, then the scope of work of the RDC could be shifted, where we could try to look at flux zones at the site boundary. So we would focus on the use of the MIP, because the MIP is also fairly powerful in identifying, let's say, just plume conditions, and work more maybe on groundwater data solely. So create a lot of cluster wells that can help us in defining where we need the PRB to be, let's say, more heavily injected, and where we can start to sort of phase out the injections as we reach the boundary of the plumes. Still, if we have access to the source areas within the site, but the remediation can only be performed within the site boundary, we would still try to aim at assessing the total soil mass that is present within the source, so that we can design the PRB with an idea of how much contaminant mass could hypothetically flow through the site boundary zone.
Okay, excellent. We've got one more, and it says, does the software allow defining limits of concentration for on and off-site screening levels? Meaning, if you have a more stringent off-site cleanup standard, can the setting allow showing this on either side of the property line?
Yes. So the way that we can visualize data is truly, it's almost, there are endless ways of visualizing data. We can clip off specific part of the property, so we can tell the software, look, only visualize data that are past a specific, let's say, XYZ point. We can play with the concentrations, so we can tell the software, show me only concentrations within this range, or within this depth interval. So we can truly play with all the features that a client may need to visualize.
Yeah, and actually, there's one more question that kind of ties on to that is, can you add geologic information in these models as well? Yes.
The answer, I can scroll back to one of the slides. So if we take, for example, this cross section for the site where we did this 125 MIP, by making sure that you have a properly calibrated EC when it comes to your MIP tooling. For example, this cross section shows you the groundwater plume concentration. So in this case, you can see a hot spot and then the plume kind of deepening. This is a chlorinated site. But by following the range of the EC, you can get a sort of general idea of the type of lithology. So in this case, we have been able to get a proper picture, because we knew that at this site we had soft clays in the upper formation, and then we knew that the water table would sort of like slowly start at deeper and deeper levels as you moved from east to west in this case. And here you can clearly see through the EC data that the groundwater contamination starts at, here it's about 10 meters below ground level. You can see the presence of a clay formation deepening from west to east, from east to west, and the plume kind of following those silts and sands layer that starts at a deeper and deeper level as you go through towards west. So we are able to work on the lithology data as well.
Great. Well, those are all the questions that came in. I guess one thing to note is that this is being recorded, and in probably early next week, we'll have it posted, and we can go ahead and Giorgio can get a link out to you if you're interested in sharing this with colleagues or clients. So, Giorgio, I'll let you wrap it up.
Thank you so much, Mike, and thanks for all the participants to have joined the first webinar session. We'll be back on June 20th with the follow-up of these sessions, which will take us to what we do with the RDC data and how we implement in the field our in-situ remediation, which is, as we discussed, mostly based on injections. In the meantime, if there are any questions or that you have, you're more than welcome to contact us at Ejlskov on our webpage. You can find all our emails and phone numbers. And similarly, if you have questions to AST and RPI, you can find them on their webpage and LinkedIn contacts. Thank you so much, and have a good afternoon, everybody.